This is SpaceTime Series 23, Episode 72. Coming up on SpaceTime. A full accident investigation underway into the cause of a multi-million-dollar Electron rocket failure. A strange galactic structure near the centre of the Milky Way. And astronomers create the most detailed map yet of the red supergiant Antares. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A full accident investigation is now underway to determine the cause of a failure in an Electron rocket during the second stage of its ascent to orbit. The flight, named Pixar It Didn't Happen, was the 13th mission for the New Zealand-based Rocket Labs company, which has had a seemingly stellar reliability record until now. The 17-metre-tall liquid-fueled Electron rocket blasted off normally from its Mahia Peninsula Launch Complex on New Zealand's North Island east coast.
We've dubbed this mission Pixar It Didn't Happen in reference to some of the payloads on board this flight, and this is a special one as it will be Rocket Lab's lucky number 13th Electron launch. Our launch operations team has been working through the night to prepare for liftoff this morning at 9:19 a.m. local New Zealand time. Payload integration took place in the clean rooms at LC-1 in the days leading up to this mission before Electron was rolled out from the hangar down the 170-meter runway to the pad. Fueling with RP-1 and liquid oxygen has been completed, and coming up shortly, our launch director will conduct the go, no-go poll. This poll will confirm that the vehicle, satellites, weather, and range are all green for launch.
Stage, there you go.
Stage is go.
Avionics.
Avionics is go.
FTS.
AFTS is go.
GNC.
GNC is go.
BMS.
BMS is go.
Beacon.
Beacon is go.
RF.
RF is go.
T1.
T1 is go.
GC. Go. LS.
BLS is go.
RSO.
RSO is go.
MET. MET is go. MM.
MM is go.
LD sub.
LD subs go.
And executive.
Executive is go for launch.
All stations LD on mission.
Today's launch is headed to a circular 500-kilometer low Earth orbit at a 97-degree inclination and is carrying 7 satellites on board Electron.
Stage 1 and Stage 2 high voltage pump lips have passed and engines are ready.
Stage 1 and Stage 2 high voltage batteries ready for flight. Avionics terminal checks complete.
All avionics on stage, thank you. And GCLD on mission. LD pad ready for launch.
In recent years, we've been focusing heavily on building up rapid production and launch capabilities for our Electron rocket. Right now, the team rolls a complete vehicle off the factory floor once every 18 days, all in pursuit of our ultimate goal to launch weekly missions in the near future.
All stations, this is LD on mission. From now on, there should be no red flags in your LCCs. Beacon, please confirm flight computer as goes green.
All as goes green.
Beacon, please lock auto sequence and confirm.
Auto sequence locked.
Stations LD on mission. We're currently go for auto sequence start and confirm LD is go for launch.
Vehicle is on internal power.
Pressing locks.
Locks load is complete. System is in recirculation. Anti-gas ring
Pressing carol.
Stage 1 and Stage 2 are pressed.
High flow engine purge enabled. Water deluge is active.
Re-readying engines.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
Discharge is nominal.
We're at T plus 45 seconds into flight, and we've had a successful liftoff from Pad A at Launch Complex 1. Next up will be Max Q, which is the point when the rocket is under the maximum amount of aerodynamic stress during its ascent.
Vehicle is supersonic. Pass through Max Q.
There's that call out from the team in Mission Control confirming Electron has passed through Max Q. Coming up are 3 events which will occur in close proximity.
AOS at Chatham
First,
Station.
the 9 Rutherford engines will power down on the first stage, commonly known as main engine cutoff, or MECO,
Guidance is
before
nominal.
Stage
50
1 and
seconds remaining.
Stage 2 separate. Then the
Stage two
vacuum-optimized
propulsion
engine
is
on Stage
holding
2 will
nominal.
ignite as the vehicle continues onward.
Entering Stage 1 burnout detect mode.
The first stage performed nominally with main engine cutout, stage separation and second stage ignition, all happening on schedule just as expected.
And MECO confirmed.
We've had a clean Stage 1 and Stage 2 separation. Electron is continuing on nominally, the nozzle on that second stage engine beginning to glow as it makes its way to orbit. And we're now at T plus 3 minutes, with fairing separation coming up in a few seconds.
Fairing jettison.
And there goes the fairing flying away from the vehicle there. The payloads are now exposed, ready for deployment. Continuing to climb at 9,500 kilometers per hour, and Electron is currently at 140 kilometers altitude. We're now 4 minutes into flight, and Electron is continuing to look good. We've got a couple of boxes left to tick off ahead of kick stage separation, those being battery hot swap and second engine cutoff coming up shortly. Electron is soaring to space at a speed of 10,900 kilometers per hour.
Stage 2 propulsion is nominal.
Now in about 90 seconds time, Electron will perform its battery hot swap. The pumps on the Rutherford engine are powered by batteries, and once these have been depleted, we swap power over to a new battery, allowing us to save mass on the way to orbit.
It's nominal, 200 seconds remaining. Altitude is 190 kilometers and the speed is 3.8 kilometers per second.
HV battery discharge nominal, approaching hot swap, roughly 30 seconds.
The first signs of a problem occurred during the second stage engine burn when the video feed suddenly stopped 5 minutes and 41 seconds into the flight. Telemetry continued for a few more seconds, showing a sudden and telltale drop in acceleration. At the time, the rocket was travelling at 13,700 kilometres per hour and climbing through an altitude of 194.8 kilometres before falling back to the surface and burning up in the atmosphere less than 1,000 kilometres downrange above the South Pacific Ocean.
Okay, all stations on mission coord. Initiating the SAP response plan.
So as you can see, Electron is at 13,700 kilometers per hour, is 191 kilometers above the Earth's surface as we're waiting for battery hot swap. At this time, it looks like the signal for our video feed has become too weak to receive.
The mission had been moved forward by a day to avoid predicted bad weather. It was the second Electron launch in just 3 weeks and marked the company's fastest turnaround time between missions so far. Rocket Labs is now working with the Federal Aviation Administration in the United States to identify the cause of the problem. The mission's primary payload was the 67-kilogram Canon CSat-1B Earth imaging satellite, which was to be deployed into a 500-kilometre high sun-synchronous orbit. Also aboard for the ride were 5 one-planet SuperDove Earth observation nanosatellites and the Faraday 1/6 unit CubeSat for the British company In Space Missions, which is carrying numerous technology experiments. Rocket Lab's only other failure so far was on its very first mission back in 2017, which failed to reach orbit due to a telemetry issue, not a rocket problem. This is SpaceTime. Still to come, the strange galactic structure near the centre of the Milky Way galaxy, and studying the red supergiant Antares. All that and much more still to come on SpaceTime. Astronomers are studying a strange unexplained structure known as the tilted disk located near the centre of our Milky Way galaxy. The tilted disk is an elongated ring-like longitudinal cloud of ionized hydrogen located inside the galactic central bar and apparently distantly surrounding Sagittarius A star, the supermassive black hole at the centre of the Milky Way. While hydrogen close to the galactic centre is being ionized by stars, the energy source ionizing the tilted disk remains a mystery. But now, thanks to some 20 years' worth of observations, astronomers have finally figured out just how much energy permeates the centre of the galaxy. Reporting in the journal Science Advances, they claim the Milky Way centre occupies a middle ground of galactic radiation levels known among astronomers as a liner-type galaxy. The discovery could one day help astronomers track down exactly where all that energy comes from. And understanding the source of the radiation could help explain not just the nature of the Milky Way, but also countless other similar galaxies. In many ways, the Milky Way is among the most mysterious galaxies. Although we call it home, our view of the galaxy's dense and active centre is blocked by immense clouds of gas and dust. It's like trying to work out the shape of a forest when you're stuck in the middle of all the trees. And that's where WAM, the Wisconsin H-alpha Mapper Telescope, comes in. A few years ago, University of Wisconsin-Whitewater professor Bob Benjamin noticed an anomaly while reviewing 2 decades' worth of information gathered by WAM about ionized hydrogen gas across the galaxy. Gas that's ionized has absorbed enough energy to strip off its electrons, and it gives off a red hue which telescopes like WAM can capture. Beneath all the dark gas and dust towards the centre of the galaxy, WAM detected a protruding bubble of ionized hydrogen that appeared to be heading towards the Earth, which shouldn't be possible because of the rotation of the galaxy. Now, because this bubble's extending away from the heaviest clouds of dust, it acts like a sort of window, allowing researchers to see deep inside, further towards the centre of the galaxy than would normally be possible. And measuring how much of the gas was ionized could tell them how much radiation existed in the galactic centre. So Benjamin and colleagues set WAM sites squarely on this protruding bubble to gather additional information on the ionized nitrogen, oxygen and hydrogen that resided there. By combining this raw data from WAM with new and updated modelling, the authors were able to estimate the three-dimensional size, location and composition of the ionized gas. The results showed there was a large amount of ionized gas permeating the centre of the Milky Way which had never been seen before. They also found that the composition of the ionized gas and the nature of the radiation producing it changes as you move away from the galactic centre. And that suggests that what's happening at the very nucleus of the galaxy, close to the central supermassive black hole Sagittarius A star, is different from what's happening a little bit further away. The overall radiation in the galactic centre is what places it into this category known as LINA. About a third of all galaxies we see are classified as LINAs. It's sort of a catch-all term for galaxies with more radiation at their centres relative to galaxies dominated by stars, but still less radiation than active galactic nuclei, which are actively feeding supermassive black holes. The authors say the tilted disk's unusual trajectory on an orbit headed towards Earth is due to the elliptical rotation of the bar of the Milky Way. However, the source of the radiation in the Milky Way's tilted disk, as well as in other LINA galaxies, remains a mystery. But now that we know that the Milky Way falls into this category, it offers a chance for up-close observations of radiation sources to try and pin down just what is creating all that energy. This report from the University of Wisconsin.
Within the central bar region lies a mysterious structure called the tilted disk that is made of ionized gas. Just a small piece of this tilted disk is visible. It peeks out through a hole in the dust close to the center of our galaxy, allowing visible light to pass through. The tilted disk gets its name from its orientation that appears tilted compared with the rest of the Milky Way. Scientists have used WAM, or the Wisconsin H-alpha mapper, to discover a faint red glow of light that is a telltale signature of ionized gas. By comparing other colors of visible light coming from ionized hydrogen, nitrogen, and oxygen, scientists can diagnose the source of ionization. They find that close to the nucleus of the galaxy, gas is ionized by newly forming stars. But as you move further away from the center, things get more extreme and the gas becomes similar to a class of galaxies called liners. This is much different than how gas outside the bar is classified. This mysterious type of gas has an unknown source of ionization, and the Milky Way can now be used to better understand its nature. WAM and this research are funded by the National Science Foundation, and the unique telescope is the only one in the world powerful enough to see the faint glow of the tilted disk. The research was led by scientists from the University of Wisconsin and Embry-Riddle Aeronautical University and is published in Science Advances.
This is SpaceTime. Still to come, astronomers create the most detailed map yet of the red supergiant star Antares, and later in the science report, new data shows that heat waves are becoming hotter, longer and more frequent all around the world. All that and more still to come on SpaceTime. Astronomers have created the most detailed map yet of the red supergiant star Antares. Red supergiants like Antares and its better-known cousin Betelgeuse are bloated, relatively cool stars nearing the end of their lives. Through their vast stellar winds, these stars launch heavy elements into space, thereby playing an important role in providing the essential building blocks for future generations of stars, and ultimately for life as we know it. But there's a mystery as to how these enormous stellar winds are launched. And the detailed study of the atmosphere of Antares, the closest red supergiant to Earth, provides a crucial step towards that answer. Antares marks the heart of the Scorpion in the constellation Scorpius. The name Antares means rival of Mars because of its appearance and location, which appears to be opposite to Mars in the sky. Despite being some 550 light-years away, Antares is still the 15th brightest star in the night sky. And the reason it's so bright is because it really is one of the biggest known stars in the universe. In fact, it's enormous, some 18 times the mass of our Sun, 10,000 times the Sun's luminosity, and at least 883 times the Sun's radius. If Antares were placed at the centre of our solar system where the Sun is, its visible surface or photosphere would engulf Mercury, Venus, Earth, Mars and the asteroid belt and extend almost as far out as the orbit of Jupiter. To better understand what's happening, astronomers have used the unprecedented sensitivity and resolution of both ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in Chile, and the National Science Foundation's Carl G. Jansky Very Large Array Telescope in New Mexico. Combined, they studied the size and temperature of Antares' atmosphere, from just above the star's visible surface, the photosphere, through its chromosphere, all the way out to the stellar wind region. The end result is the most detailed radio map yet of any star other than the Sun. ALMA observed Antares close to its photosphere in shorter wavelengths, and the longer wavelengths observed by the Very Large Array revealed the star's atmosphere further out. Seen in visible light, Antares' diameter appears to be 883 times larger than the Sun. But when ALMA and the Very Large Array revealed its atmosphere in radio wavelengths, the red supergiant turned out to be even bigger. The longer wavelengths of the Very Large Array revealed the supergiant's atmosphere out to nearly 12 times the star's radius. The study's lead author, Eamon O'Gorman from the Dublin Institute for Advanced Studies, says the size of a star can vary dramatically depending on what wavelength of light you're observing that star in. The radio telescopes measured the temperature of most of the gas and plasma in Antares' atmosphere, and most noticeable was the temperature in the chromosphere. This is the region above the star's surface which is heated up by magnetic fields and shock waves created by the vigorous roiling convection of the stellar surface, much like the bubbling motion in a pot of boiling water. Not much is known about chromospheres, and this is the first time that this region's been detected in radio waves. Thanks to ALMA and the Very Large Array, the authors discovered that the star's chromosphere extends out some 2.5 times the star's radius. Now, by comparison, our Sun's chromosphere is only 1/200th of its radius. They also found that the temperature of the chromosphere around Antares is much lower than previous optical and ultraviolet observations had suggested. In fact, it peaks at just 3,500 degrees Celsius, after which it gradually declines. Now, by comparison, the Sun's chromosphere reaches temperatures of almost 20,000 degrees Celsius. O'Gorman says the difference can be explained because the radio measurements act like a sensitive thermometer for most of the gas and plasma in the star's atmosphere, whereas previous optical and ultraviolet observations were only sensitive to the very hottest gases and plasma. Astronomers also, for the first time, saw a clear distinction between the chromosphere and the region where the stellar winds start to form. In fact, in the Very Large Array image, a huge wind is visible ejected from Antares and lit up by its smaller but hotter companion star Antares B, a spectral type B blue-white main sequence star more than 7 times the Sun's mass and 5 times its diameter. Antares is reaching the end of its life. As it runs out of fuel, the balancing act between the outwards push of nuclear fusion and the inwards pull of gravity will end, causing the star to collapse and go supernova. And that's likely to happen any time now, which in astronomical terms could be within the next million years or so, or it could be tomorrow. When it does explode, it'll appear as bright in the Earth's sky as the full moon, and it will be quite noticeably visible even during daylight hours. The study's findings are reported in the journal Astronomy and Astrophysics. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that heat waves are becoming hotter, longer and more frequent in almost every part of the world. And the findings reported in the journal Nature Communications show they're also accelerating. In order to have a better understanding of what's going on, researchers have developed a new heatwave metric, which they're calling cumulative heat, which shows just how much extra heat is produced by these heat waves. It reveals that during Australia's worst heatwave season, an extra 80 degrees Celsius of cumulative heat above the long-term average was baked into the land. Meanwhile, in Russia and the Mediterranean, individual heatwaves saw an extra 200 degrees Celsius plus of cumulative heat compared to their long-term averages. A new study has found that no matter how you smoke, be it cigarettes, vaping or water pipes, it's still really bad for your body. A report in the European Heart Journal has confirmed that all forms of smoking stiffen arteries, cause inflammation, and damage DNA. And this leads to a variety of health problems, including increasing the risk of being infected with COVID-19, suffering worse symptoms, and a greater likelihood of dying from it. The authors say quitting completely is still the most effective way to halt heart and lung issues down the line. A new study warns that kids with certain sleeping problems in childhood may be at a higher risk of developing psychosis and borderline personality disorder in adolescence. The findings, reported in the Journal of the American Medical Association, are based on a study of 13,000 children over 13 years. The authors found that kids who work more frequently at night at 18 months of age and kids who have less regular sleep routines at 6 months, 30 months and nearly 6 years of age were also more likely to develop a psychosis in their teens. They also found that those who slept for a shorter time period at night and those who had a later bedtime at 3.5 years of age also tended to show higher rates of borderline personality disorder symptoms. The authors say the findings could help identify kids who might be at higher risk of psychosis and could lead to sleep interventions that may even prevent the onset of these mental disorders. A new study has found that humans invented string at least 120,000 years ago. A report of the journal PLOS ONE found that modern humans were collecting perforated cockle shells and then wearing them on strings around their necks at least that far back in antiquity. The naturally perforated shells were found in a cave in Israel. But to work out exactly how and when they were used, researchers collected new shells and then simulated the different wear patterns against leather, sand, stone and string, and then compared these wear patterns with the original shells. They found that the wear patterns on the simulated shells from contact with a string, as well as from shell-to-shell contact, was the closest match, suggesting that the shells were hung close together on a string. The scientists say this suggests that string-making technology probably first developed sometime between 160 and 120,000 years ago, which I guess means they've now tied it all up in a nice neat bow. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.